Hey guys, Mr. Marone here. I just wanted to bring you an online version of today's lecture on reflections and rotations, and wanted to just highlight some stuff for you that were in your notes that you'll receive in class today, so you can always use this to go back to if you need. Okay, the first thing we're going to start with is the reflection. Okay, so reflection always goes over some line that's given, and just so you see it, we do use r with a lowercase r with a subscript m to represent our line. Okay, so to give you an example, if we wanted to reflect over the x-axis, that's how it would look, reflect x-axis. Okay, and as we've said already, it's an isometric transformation. Okay, so it is going to map onto itself, and it's going to keep the figure congruent. Okay, each one has a point that's the same distance from our line of reflection. Okay, that's a big key for us, that when I look over here at A and A prime, these distances are the same thing. That's what those tick marks mean. That's going to have an original distance that's the same from image to pre-image and vice versa. Okay, and one thing that we just want to highlight again is that because this is an isometry, okay, the image does not change size or shape. It's the exact same image. Okay? The last thing that's kind of a cool factor is that this line M here is actually the perpendicular bisector of the distance between the 2 points and the line of reflection itself. So if we were to just highlight this, you've got the points A and A prime, okay, and they are reflected across line M. The line that we have between them is actually perpendicular to our line M. Okay, and that's true, as you can see here, for B and B prime and C and C prime. So all three of these things that we've highlighted are true for every one of our reflected figures. Okay, so now the last thing that I want to point out here that we highlighted a little bit in the previous slide is that if I've got a point like I have here with point P, if it's not sitting on my reflection line, then I have the distance from P to P prime is perpendicular to my line of reflection. Okay? If the point is sitting on the actual line of reflection, so if we have a point, if we're reflecting over a y-axis and the point is on the y-axis, then the point for our image and our pre-image are the same thing. Now we have a couple characteristics here that we want to look at, and we're going to look at all three of our isometric transformations this way. So the distances from pre-image to image, okay, does this create a congruence between all of my points? And that is no. They are different when we go from pre-image to image for each individual point. Okay, so in general, A prime, that distance of our new point from our old point, is not going to be equal to B prime. Okay, those are not going to. It's all about the line of reflection. Now, the orientation will not be the same either. It's going to be different. We've moved our figures. Even if we look back to our example on the first page, the one figure, kind of C, turns to the left. In its reflection, it turns to the right. So the orientation is going to be different. Okay, and it's actually always going to be reversed. Okay, so no matter what we do, it's going to be reversed. And then the only special point that we really have that we're going to talk about is points on the line of reflection. Okay, so we saw that here with our point on the line of reflection here in B. That's going to be our special case. If a point sits on the line of reflection, then the pre-image and the image are the same point. Now, when we talk about reflections and we look at the idea of orientation, what does it mean to have orientation? Okay, and that simply means it's the ordering. It's the ordering of the points. Okay, so what we do is we read things clockwise. So if I draw in a figure here, and I've got point A, point B, point C, I read it that way because it goes clockwise. Okay, just like we would read it other ways. So when we reflect across this line, we've got A prime, we've got B prime, and we've got C prime. If we look at this, if I were to read clockwise like usual, I have A prime, C prime, B prime, which isn't the same. So we have to be really careful about that we know there's different orientation when we reflect something. So that's where, when we look back at our previous thing where we said that orientation was different, that's really crucial. It's going to flip. Okay, reflection is a flip, so we want to make sure that we are noting that as we go through things. Okay, so that's reflections. We're going to deal with them a lot. There's just some cool characteristics of reflections that I wanted to make sure we highlighted. Okay. So let's go on to the rotation. So the rotation is, once again, isometric, and it turns a figure about a fixed point. Okay, and we call that the center of rotation. So wherever we are rotating around, that's our center. Okay, and if you look at the notation that's in here, we've got a capital R for rotation. That's why we use the lowercase one for reflection, so we know which one is which. The next thing is where the center is, so it's going to give you some point. Okay, if it's the origin, where we deal with it most of the time, you'll see a capital O. Okay, and then it will give a degree measure. That's the amount of turn that we're going to have. Okay, and once again, the figures are the same size and shape, but they're going to be turned in different directions. So just be aware of that as you go through. There will be different directions, as we can see up here in our picture. Okay, and they've got these round dotted lines to indicate where we've turned these. They are all what are called concentric circles, or concentric circles, and they all are sitting on that same center, so they all really are similar circles, as we'll deal with later on. And once again, just see this notation here, how we refer to rotations. Now, we've got a bit of a definition here. And just to translate the kind of mathy definition for you, it tells us that we've got an isometric transformation here, and it maps every original pre-image point to a new point, point P prime, for each one. And it tells us that if a point is not on point, if P is not point O, so if these are different points right here, then this distance here, OP, and OP prime are the same thing, and the amount that we've turned is our degree measure. Okay, so if I move a point from my pre-image to my image, and they're not the same thing, okay, if it's not the origin point, then we've got a bit of congruence here, and we also have our turn. Okay, and if point P is on point O, it's the same exact thing, then those points are the same thing. Just like we saw with our reflection. If I rotate a figure around one of the points, that point isn't going to move. Picture putting your finger on a piece of paper and rotating it around your finger. The point that's under your finger isn't going to move at all. So that's something to definitely note as we look through these. Now, as for characteristics, when we look at the distance from our pre-image to our image and compare whether or not they are the same, they are in fact different. And I'm going to show you a little example. So I've got my vertex here, and I'm going to draw in my two pieces. I've got point B and I've got point A. Okay, we're going to map these across. So I've got B prime and I've got A prime. And you can clearly see that this length here, let me change colors so we can see it better. This length here is definitely smaller than this length here, so they are different. Okay, it travels along an arc, but those arc lengths are going to be different the further out that you move. Okay, so generally, A prime, the distance there, is not equal to B prime. Now, the orientation of the figure stays the same. It's not going to be flipped like we saw with our rotations, or our reflections, sorry. It'll be the same. Okay, it might have, this figure is our original, so we'll call this one A, B, C, and then when we rotate it, it's still going to look that way. A prime, B prime, C prime. It's just turned. Okay, so we notice that they just have swiveled a little bit. Okay? And our special point here is known as our center of rotation. Okay, it's our center of rotation. And it is the only unchanged point in a rotation. Okay, it's the only unchanged point in a rotation. Now, to finish this idea up of rotation, we've got to discuss direction. Okay? If you notice here, we can either go to the left, counterclockwise, or to the right. The rotation is going to tell us based on the amount of degrees, and it's going to give us a positive or a negative. Okay, so if you see a positive degree, if we want to turn 75 degrees, that's telling us to turn counterclockwise. Okay, where if they told us negative 30 degrees, that tells us to go clockwise. So our positive rotations are always counterclockwise. And our negative rotations are always clockwise. And as you can see here, it's a positive rotation up here. Let me change colors again. Go purple. It's a positive rotation, so it's going to go counterclockwise. So that's a bit of a hit on all of our notes that you will have seen in class today if you were here for school and if you didn't get pulled for our Beyond Point initiative. If you have any questions, please email me. We will spend time with this all next week, Monday, Tuesday for sure, and then we'll keep building on it from there. But I wanted to make sure you guys did see the notes. So if you have questions, please feel free to ask them, send me an email, or go onto my website, maroonmath.com. Have a great weekend, guys.